Hello, I am Emre from Huawei Developers and welcome to Huawei tutorial series. Today I'm going to talk about augmented reality. So what is AR? AR is an interactive experience of a real-world environment where the objects that reside in the real world are enhanced by computer-generated perceptual information, sometimes across multiple sensory modalities including visual, auditory, haptic, somosensory, and olfactory. Use AR Engine to build a brand new visual experience and interactivity. Augmented reality adds virtual interactive experience in real-world objects. It uses computer-generated perceptual information to enhance users' sensory experience in a dimensional digital world. AR market reaching $1 billion each year, and its key drives of the new IT system. That's because AR apps and hardwares promise to add value to virtual every industry. From education to tourism, here are some use cases for AR technology that are set to emergence in near future. Medical training. From operating MRI equipment to performing complex surgeries, AR techs holds the potential to boost depth and effectiveness of medical training in many areas. Retail. Users can view their products they might be interested in buying in the store and customize it using the app to see which color and features they might like. Or, seeing the feature of the restaurant menus is easier than ever before. With new augmented reality technology serving up 3D burgers, desserts, and other appetizing treats via smartphones and tablets. Repair and maintenance. One of the biggest industrial use cases of AR is for repair and maintenance of complex equipment. Whether it's a car motor or a MRI machine, repair and maintenance staff are being to use AR headset and glasses while they perform their jobs to provide them with useful information on spot, suggest potential fixes, and point out potential trouble areas. This use case will only continue to get stronger as machine-to-machine IoT technology grows and can feed information directly to AR headset. Design and modeling. From interior design to architecture and construction, AR is helping professionals visualize their products during the creative process. Use of headset enable architects, engineers, and design professionals step directly into their buildings and space to see how their design might look, and even make virtual on-the-spot changes. We can give some use cases for business logistics, tourism industry, classroom education, public safety. Currently, AR Engine provides three types of capabilities. Thanks to these capabilities, AR Engine is able to better perceive real-world environments in a building hybrid world in which physical and virtual objects interact seamlessly and enable to your app provide for seamless virtual-physical convergence. Motion tracking follows device location and position relative to their environment and establish a unified geometric space between the digital and physical worlds. Environment tracking records illumination, plane, image, object, surface, and other environmental information to help your apps merge virtual objects into scenarios in the physical world. Returns real-time information about human bodies, faces, and hand gestures for your users to interact with virtual objects. AR Engine continuously tracks the changes in the position and orientation of the device relative to the surrounding environment and establish a cohesive geometric space that bridges the virtual digital world and real world. Motion tracking currently supports movement tracking and heat test. Movement tracking. This feature continues to track changes in the position and orientation of the device, with a high degree of reliability and simultaneously output 3D coordinates relative to the surrounding environment. Heat test. Users can select a point of interest in a real environment by tapping the device screen. AR Engine will use the heat test technology to map that point of interest to a point of interest in real environment, from where a ray will be emitted pointing to the position of the camera, and return the intersection point between ray and plane or feature point. In this way, your user will be able to interact with virtual objects. AR Engine also tracks the illumination, plane, image, object, surface, and other environmental information to assist your apps in integrating virtual object into physical world in the same manner as in the real scene. Environment tracking currently supports following capabilities: lighting estimation, plane detection, image tracking, environment mesh, plane semantics, 3D cloud recognition, and target semantics. AR Engine tracks real-time information related to human bodies, faces, and hand gestures to assist your apps in implementing natural interaction between users and virtual objects. Gesture recognition. AR Engine can identify multiple types of gesture, output the identified gesture types, and provide the screen coordinates of the palm detection box for both the left and right hands. Gesture recognition allows you to place virtual object in the user's hand and activate certain status based on the changes of the hand gestures, providing for fun interaction within your AR app. Body tracking. This feature identifies and tracks 2D position of 23 body skeleton points. Human body mask. This feature recognizes and tracks the area where a person is located within current image and provides for deep related information. Health check. AR Engine detects facial health indicators and calculates key health information in real time to provide the health check function, including the heart rate, respiratory rate, facial health status, and heart rate waveform signals. Thank you for watching. For more detailed information, you can visit developer.huawei.com.